Hello, boys and girls. We are in our last lesson for topic 16. We are going to continue to look at some shapes and polygons today, but we're going to be looking at whether or not those figures have symmetry. All right, and that's um, when you look in a reflection of something, or if you were to fold something in half, it means it would line up perfectly. Everything would be the same size, shape, and in the same place on either side. So we're going to learn to be able to look at those shapes and identify if there is a line of symmetry. And if a figure has a line of symmetry, we would call it symmetric, which, as you can see in our two words right here, we have symmetric, which is where something can be folded on a line to form two equal halves. Okay. And then where that fold falls is called our line of symmetry. The key to this line of symmetry is it needs to go through the middle of a shape. It cannot go through the edge. It can't go through on an angle in a corner. It's got to go cutting right through in the middle of that shape. So if we take a look at this square right here, okay, we have this first line of symmetry that goes right down the middle from top to bottom. So both sides, I'm going to shade this side and this side are completely the same. Okay? If I was to erase this, and now I could also have a line of symmetry this way through the shape. It's, again, right through the middle, only this time it's going side to side. That means this top piece and this bottom piece are symmetric or equal or the same on both sides of that line. The final way that this square can be cut in half is this angle line. Now, it still goes right through the middle. It goes from corner to corner. And we have a triangle on both sides of that line then that has now been formed in that square. So the line of symmetry in each case went right through the middle of the shape. It can go on an angle through the shape. It can go on up and down vertically. It can go side to side horizontally, as long as it's going right through the middle of that shape. So there are, and I forgot to do one, the other angle this way. Okay, this is the fourth way that this shape has it. So that's why you see this underneath, 4 ways. There are 4 different lines of symmetry. 1, 2, 3, and 4. Okay? All right, let's take a look at a few more shapes here. We're going to look over on this side first. Okay, we're going to look at number 1. Okay, and I know it says no there. They want to know if each one has a line of symmetry or not. And I left the no there for a reason. I want us to look at why that does not have a line of symmetry. If you look, it goes right through the middle like it's supposed to. And yes, it is a rectangle, so the tops and bottoms are the same. However, this little tiny square rectangle in the middle that's white and not yellow does not appear down here on the bottom. So therefore, that is not symmetric because it is not the same on either side of that line. Whereas if you look at number 2 over here now, this line right here goes vertically through the shape. And if you look, if I was to take that shape off this page and fold it, this side is exactly the same as this side. So therefore, that is a symmetric shape. A few more things to look at. It is important to know that a figure can have more than one line of symmetry. A triangle, for example, equilateral triangle, I'll do the best I can, or an isosceles. If I draw my line, this is only going to have one line of symmetry. I can't cut it this way because it won't be the same on the top and bottom. Okay, so a triangle will only have that one line of symmetry. Whereas if we look at this rectangle right here now, we have one line of symmetry that goes vertical, and we have one line of symmetry that goes horizontally. Unlike the square on the other slide, we cannot go diagonally with this rectangle because this corner when folded would be here and this corner would go there. So, and we'll practice that with a piece of notebook paper tomorrow. But this rectangle only has those two lines of symmetry. Okay, I'll clear that off. All right, let's look at this next figure here. So we said this rectangle had two lines, two, okay? Our hexagon here has many, many, many lines. Okay, we have this line up and down, okay? We have the line that goes horizontally, but then we can also go from each vertex to the opposite one. So this is opposite of this over here. I can go from this vertex down to that vertex to vertex, okay? There's two more ways in this hexagon. I can cut it this way, going from opposite side to opposite side, and I can go from this side to this side. So there, if I count, there's 1, 2, 3, 4, 5, and 6. There's 6 lines of symmetry, okay? All the vertices that are opposite from each other create a line of symmetry in the shape, and the opposite sides create lines of symmetry. Just because this is a hexagon and there's 6 lines of symmetry does not mean that applies to all shapes. So for example, I'm going to draw it as best as I can. This pentagon, yes, it has 5 sides, okay, 5 vertices. It does not have 5 lines of symmetry like our triangle. This only has 1 line of symmetry. This is the only way I can cut that shape in half where both sides would be the same. So don't be tricked by the fact that this hexagon has 6 lines of symmetry. It does not work just based on the number of sides and vertices because this pentagon only has 1 line of symmetry. Our last figure down here on the end has no lines. There are shapes that can have absolutely no lines of symmetry. No matter which way I cut this, horizontally, vertically, diagonal, it's never going to have a line of symmetry. It will not be the same on either side of the line. And this applies to letters. For example, we have the letter E. Technically, depending on how you write this E, you could have horizontal, vertical, or horizontal line of symmetry, sorry. We have a capital letter D. This could have a horizontal line of symmetry. Okay, what if I was to look at a lowercase h, for example, though? This letter horizontally does not work, and vertically does not work. So again, that's another example of something that does not have a line of symmetry. So your practice problems tonight are going to ask you to do just that. You're looking to see where you can draw that line of symmetry and see if it's equal or the same on both sides wherever you draw that line. Just remember that the line needs to go directly through the middle of that shape, whether it's vertically, horizontally, or diagonally like we've been doing. Okay? All right. Thank you, boys and girls.